Hi and welcome to Squizz.com, the connected marketplace. Today we'll be looking at the changes we've made to the Squizz.com connector software in the 1.20 releases and the 1.20.1, 0.2, 0.3, 0.4 incremental releases. The Squizz.com connector is a free piece of software developed by us that allows the business to connect any of its business software, databases, spreadsheets and files into the Squizz.com and Todex platforms, allowing businesses to save and make more money by automating data management, data transfer between its systems and other supplier and customer systems. Now you understand what the connector can do, let's look at the latest changes made in the 1.20 release. These releases adds 2 new features and 13 improvements into the connector software. Within the generic adapter's JSON XML data source, we've now added support to be able to read and convert CSV text file data retrieved from HTTP requests and files into the JSON data format. The data source has now been renamed to the JSON XML CSV web service file data source. Additionally, within the JSON XML query browser, it also now supports reading and converting CSV text file data that are typically edited within spreadsheet applications into JSON from HTTP requests and files, the raw data tab as well as the request body tab. The query browser has also been renamed to the JSON XML CSV query browser. Within the generic adapter as well as the JSON XML CSV query browser, we've added 7 new JSON XML CSV field functions, that is a SUBSTRING, INDEXOF, rand, length, CTRLChar, HMAC, and pad functions. And all these functions provide additional flexibility, being able to manipulate data coming from JSON-based data sources such as web services and files. The product images data export now supports downloading product images from externally hosted web services and websites. Then after being downloaded, it can then upload these image files into the Todex Ecommerce platform. This can greatly automate product image importing when images are hosted on an external website such as a supplier's or manufacturer's website. You can set the image file path to a URL within the product images data export within the generic adapter to be able to then allow the images to be downloaded by the connector and then uploaded to the associated e-commerce system. Within the generic adapter for the cell units data export, 2 new fields have been added to be able to set the cell unit label and parent cell unit that a product is assigned to, which is required in order to show the correct cell unit label when products are imported into the Squizz.com platform. Within the product and category datasets tabs, the description fields can now be edited using a multi-line text editor. This makes it easier to view and write multi-line descriptions for both products and categories. Additionally, in the Datasets Product tab, we've added a Lock/Unlock Product ID and Code Columns checkbox to allow the product ID and code columns to stay fixed in the tab when you scroll across to update other details of a product. This should make it easier to update details when you normally could not see the product codes and ID columns. This should make it easier so you know which product you are updating data against. Within the generic adapter, we've added a new routine called the generic HTTP GET request routine that allows the generic adapter to be able to fire off a HTTP request to any configurable web server at a scheduled time period. This is very useful if you want to trigger events, actions, or polling on remote web services at regular intervals, such as making sure that a certain service is updated or running, or it runs a routine in its own system. Within the generic adapter, we've added additional data hooks for when the JSON XML CSV data source is assigned to data exports, and this allows the key ID of the last record previously returned in a page of data that's been retrieved to then be passed to the next page of data. So this is relevant for when a web service limits the amount of records that can be retrieved from it, and it must specify where the next record to start from to get the next page of records is required. If that's not enough, we've fixed a number of bugs in this connector release as well. And for anything else, you can subscribe to the Squizz.com YouTube channel to keep up to date with all the latest features we're releasing, and sign up and follow the Squizz.com platform's connector feed to receive announcements and discuss any connector topics. Without further ado, let's get into looking at the new features. Within the 1.20 connector release, we've added a new capability into the JSON XML query browser to now support reading CSV data. So now the query browser has changed its name to the JSON XML CSV query browser. If you're not aware what a CSV file is, it stands for comma separated values, and these files can be typically opened within spreadsheet applications. So if I click on this product CSV file I've got here, we can see within our spreadsheeting application where a CSV file contains a row that contains all the names of the columns. Every subsequent row represents a record that contains values for each of those columns. So in this example, this product CSV file contains 3 rows that contains details about products. In this case, what is being sold is pink, blue, and yellow sweet delicious donuts. So back in the connector, if we click on the JSON XML CSV query browser, if we choose the option to read a CSV document from the file, and then we locate that file on our file system, when I click the open button, the query browser will now try to read from this product CSV file. Now what we can do is instantly hit the run query button, and what that will do is automatically populate the JSON record set path and set the data fields. And if we also look within the record set, we can now see the data is now coming out of that spreadsheet CSV file and now is being populated. So what is happening is the query browser is reading the CSV data and it is converting it into JSON data. So as we see here, we can now see that there is an object called data records that stores an array of records which contain each of our 3 product records which have been obtained here. Now the attributes of each of those objects is based on the names of the columns that were set in the first row of the CSV file. So the query browser is smart enough that if you leave the JSON record set path empty and then you run the query, it will automatically populate it with the record set path, and it is advising to get all of those records out. And same with the columns. If the column table is left empty, it will then read all the columns from the first row of the CSV file and then automatically populate them all as well. Now the beauty for this is once the data is converted into JSON, then we can use our JSON field functions in order to manipulate the data. So this is a new capability that is added by having the CSV file converted into JSON. So let's take an example. Maybe for the average cost, we wanted to add $4 to it. So we could simply here use the calc function now, add $4 for the cost of the products. Now when we run that, we can see now that the cost started off as $3, it is now $7 for each of those products. So this is just one example of where you can use now the JSON field functions in order to manipulate data coming out of CSV files. We can do some filters, so maybe we don't want all the products out. We only may want to get out products that have a certain barcode or brand. We could add filters within the record set path to do that. We could also concatenate or join fields together. If an example in the description field, we may also want to put the description field into description 2, but we may want to combine that with the brand field. So we could then do a concatenation where we can say put the brand data, put a space in between it, and then we will put the description 1 field with that. And if we run that, we can now see the description 2 is now populated with the brand as well as then the data coming from description 1. So this is a very powerful tool when previously you were very limited on how you could manipulate data coming out of CSV files. Now it's not just files where we can get the data from, we can also get the data from a HTTP request. So we can then set the URL, such as if the CSV data was stored on a separate website, we can put in the website domain here and put in the URL in which we can then find the data for the CSV, whatever that may be. We can put in request headers, we can say what kind of method we need to use to get that data, and we can put in how long we're going to wait before we give up on getting that data out, as well as setting up all the fields itself. So this is another way in you can request the CSV data from an external web service, if that web service is hosting that data in that format. We can also get the data from the raw tab. So we can put CSV data into the raw tab itself. So there's an example where I've got CSV data that has been put in and that's also being rendered out. So you can see that the values in the CSV data are actually separated by different delimiters. So within the query browser, we now have a new tab called CSV text reader settings. So this controls how the CSV data is read. The fields can either be delimited in many different ways. So our data here, example, is delimited. Each cell in the spreadsheet is separated by a comma character, but that could easily be a tab character instead. And if that was the case, when we would update this setting to have a /t to represent a tab, the rows could be delimited with different values. So this currently it's set to, by default, it's set to a carriage return and a new line character, but your CSV data may be using a different characters to delimit the data, and you can see that within text editors when opening a CSV file what the delimiters are. So they could be separated instead by one of these single characters, or they could be separated by a completely different sequence of characters. So you can also put that into there. And then the field enclosing characters, so this denotes that there may be characters that wrap a certain field, and then those characters should not be read. They should be correctly get the value only within those cells. And then we have the fourth setting, which is the escaping character that says that if there was a quote in the middle of a cell record, then if that has a slash character, that's what this slash is representing, then it should treat the enclosing character as a literal character. So in effect, it allows that to be read. So you can change each of these settings to match the way the CSV data has been formatted for your circumstance. Do note that if you do copy CSV data into this raw tab, then by default, Windows will put the carriage return and the new line characters at the end of each line, whether or not you thought that was going to happen or not. So just be mindful of that. So generally, it's better to save the CSV data into a file and read it using the file format to make sure that Windows does not manipulate the data that would otherwise be put in the raw data tab. Now, it is also important that if your columns contain spaces within the names, then they need to be wrapped with square brackets and then a single quote character, so that way the JSON parser can correctly find the values for that. So if we take an example, in our original data here, let's put a space in the description between the numbers for each of the description fields. Now within the query browser, when we find that file, and then we click the run query, you'll see that the description fields by default already have those square brackets around those fields to make sure that we're being able to find the actual values of those fields. If those square brackets were not there, then the query browser would throw an error message saying it cannot properly parse the function. So that's an important thing to note. If your columns have spaces within there, that they need to be properly square bracket enclosed. So the next improvement we also added into the 1.20 connector release is that within the generic adapter settings, the JSON XML web service file data source type is now being changed to the JSON XML CSV web service file data source type, to denote that we can now use this data source type to also read from CSV files. So previously, the CSV files needed to use this older CSV spreadsheet file data source, but now there is really not a need to use that anymore when we can now use this other data source, and it is left there purely just for legacy reasons. So when we set up one of these new data sources, which is called reading in CSV data, when we modify that data source, there is another tab here that allows you then once again to specify the settings for how the CSV files are then rendered. And then also within here, you need to specify if you want to read the data from a CSV file or a CSV web service, you then need to change the data type to CSV. And in the protocol, if you're reading from a CSV file, you set that to file and then put in the path to the file, such as our example here. Now you don't need to put in the name of the file name. We'll do that on the individual data export where that is being set up. So once we've got that saved, we can then save those settings. And then if we then go into a data export, such as here, where we've got our CSV file, so we can assign our new data source to that. And you can see we've got now all the same settings that we had for if you're assigning an XML or reading the data export or import was assigned to a CSV or XML file. So then here within URL, we'd put the name of our CSV file. We can then set the path, which would be the data records, which automatically gets populated by the data source. And then from there, we can then set our fields. Then we can click on the test export query to use the query browser to once again to check that we can read data from the file that we were expecting. And if we were using a web service, we'd put instead the URL to where that data that is stored in the CSV format. We could also set CSV data specifically within the body of the request. So if our data source was instead set to the content body within the data export, we could then put the CSV data directly and save it within the generic adapter itself. So this extra functionality will allow you then to export data that is stored in CSV files, web services, or within the body into the associated e-commerce systems where the data then needs to be sent to. Within the 1.20 connector release, we've added 7 new JSON XML CSV field functions that allow data coming from JSON, XML, or CSV files be manipulated and modified based on using these functions. Now you can see all these new JSON, XML, CSV field functions if we go into a web browser and go to squizz.com/docs/connector. Then on the side, if you scroll down to the JSON, XML, CSV data field functions, that will give you a list of all the field functions that exist within the connector and find the details on how each work. If we go back into the connector and we open a query browser, we can actually play with these in effect. We'll firstly just read some JSON data from our raw tab, and we'll just set up some demo data just so we can play with it. So here's a very simple JSON object that I've created, and we'll just get its object and then we'll get its value just to test, and we'll give it a value. So we are reading from the JSON data and we're finding the test field, and then we are returning the test value. The first function that we're going to look at is this new function called SUBSTRING. So if we go down to its documentation, so the SUBSTRING function allows us to cut down the size of a text value that has been returned. It receives 3 arguments. We can give it the text that we want to then reduce. We can say which character should we start getting the text data from, and the end character. So if we look at this in effects, we can use the substring here. So the substring function allows for 3 arguments. We could give it the literal text, or the value, or the name of the JSON property that we then want to read the text from, and then we need to give it the position, or the index position of where the starting character as well as the ending character. So by putting in the value 3, it's saying that go to the 4th position in the string, because 0 is the starting position, and then go get me the value until the 6th index, or the 7th position of the string. So if we look at the data here, it is going to the 3rd position. So that's 1, 2, 3 is the 3rd position, and then it's stopping at the 6th. So it's going to 4, 5, and 6th position is here. So it's getting all the values in between that, which is the T and the V. So if we wanted to get the word value out of this string called test value, we would need to change this from get position 5, and we don't have to give it an end position, and if that doesn't occur, then it will get all the text characters until the end of the string, which it has done so here. In effect, with our text string here, to get out the second word within this JSON and ignore the first word. And then we can do the opposite. We may only want to get the first word out in this text string. So then we would set the starting position as 0 and set the ending position as 4 to get the first 4 characters, as such is happening here. So this function is very useful for when you want to cut down text. Now what typically could happen is if you've got a code, such as, let's say we've got a sales order and then it has a number such as this, you may not care about the prefix text that is being put at the start of the sales order. So what we could do with this is we could say for the first 3 characters, we don't really care about that prefix, and then we can remove the prefix and just return the value of the actual ID of the sales order. So that is a typical example how the substring function could be used. The next function we'll be looking at is the new INDEXOF function, and what this allows us is to get the position or the index of the first character where a matching text has been found. So if we take an example of this and we use the INDEXOF function. So we may want to know the position of where the word value first starts within this text string. So what we can do is we can give it the name of the property within the JSON or literal text, and then we can say find me the word value within its text string. So if we click the run query, you can see that this function returns a number saying what position does the first occurrence of the word value occur. So if we had multiple occurrences of the word, so let's just put a few of them, you'll notice it only ever gets the first occurrence of that word within the string. Now this is a useful function because now we know where the position of a word within it, then we can combine that with other functions in order to either remove that word or remove other words around it. So this is when the substring and INDEXOF functions come together. So if we put the substring function in, and then we're going to say from the value test value within the JSON, I want to cut off all the text before the word value appears in that string. So if we do that, if we reduce our string and run that, we can now see that it has been able to return the word value within our test data here. And we didn't have to specify the explicit position of the word value. The INDEXOF function was able to be able to determine that. So if we had more words in here, so let's just put the word example. The function will always return the word value because this index is always searching for the position where the word value appears, and it could be at the start of the string, or we could put it in the middle of the string to see how that is being matched up. So now we can see it is being able to find the position of the word value, and it's getting all the text after where that first position occurs within here, so it's matching from there in effect. Now we can do the opposite by using the substring function. We could say get me all the values before where the word value appears in the string. So then we just add the first argument to be 0, and then that's going to say get me all the characters from 0 to where the word value starts. So now we can see we're only getting the word test out. And we can see that we're getting a space because there is a space here before where the word value starts. So we could then further this by putting a trim function. to get rid of any white space that is returned from the value that we're receiving. So then we get purely just the word that. So that is an example how we can use that. And then we could, once again, position that word anywhere within our string. And we will know that it will always get all the data before that value sits there. So there's another example that is happening. If it can't find the value, so let's just change it to TO. If it can't find a value, it will return the value -1. So if we then put that into our substring function, if the substring function receives the value -1 in its position, then it will then ignore doing any trimming or doing any cutting of the text that is being found. So if we run that again, we can see that it's returning the entire value because the INDEXOF function is returning the value -1, and then the substring function saying, get me the position of -1. Well, there is no -1 position, so let's just start it off at 0 and go from there. So these two functions can work very well with each other when you're trying to find words and then to cut text from text strings that you're receiving. The next JSON XML CSV function that we've added is called the RAND function, and what this returns is a random number, and that number can be within a specified range, such as you can set a minimum number and a maximum number that is returned by this random function, and you can also set how it should round the numbers as well. So to take an example of this, if we put the RAND function into our fields and click the run query, you can see that it will generate by default a number between the value of 0 and the value of 1. So it is getting a decimal number, and you can see by default to 10 decimal places. So if we then keep clicking that, you'll see that the number keeps randomly getting generated, and then we can use this random number for all sorts of things. Random numbers may be required for using authentication with web services, or you may want to just generate a random number within a certain field in order to then populate that field. If we set a few of the arguments, maybe we want the number to start from 1 and then we want it to stop at 10. So if we put in those values there, we can now see that the number always must be within that range. The other argument we can say is how many decimals it should round to. So if we put the word 0, then we're always going to get a whole number or an integer that is returned by the function, as we can see here. Or you can say, I want to specify it to 4 decimal places. So there we go. That's the number that we are seeing there. So with this, you could make some very big numbers, generate a random number from 50 to, say, 1 million. The random function can now do that, and we'll just do that to 2 decimal places. Then when you click the button, you can see that now we can get some very big numbers, or we can get some fairly small numbers as well. And this just uses the .NET Platform's random function in order to generate these random numbers. Another JSON XML CSV function that we've added is called the length function, and this simply returns how many characters appear in a length of text that is given to it. So if we take our previous example, so we've got the sales order number field, and then we put the name of that JSON field, we can see that it has 9 characters. That is each individual character that you see here. It is counting them all up together to give you a total. So if we add more numbers here, you'll get a bigger number there, and if you take characters away from there, then you'll get a small number here. It's a very simple function, but it is useful for when you combine it with other functions, such as the substring function. We could get the length of given text, for example. Let's just put the number 111, and so it'll get the length of that, which is 3, and then it will then put the value 3 into the substring function. It will give it the property in order to get the text from, and it's saying, get me from the third character onwards, which will give us that value there. So that's one way you could use the length function. The next function that we added is this function called CTRLChar. And what this can do is can return out a control character, and a control character is a character that you typically cannot see, such as a new line character, a carriage return character, or a tab character. So this function allows us to place these literal characters into a text string. So let's take an example. If we put a /tab character within the text, now you do have to double escape the slash before it because /t would otherwise put in the tab character by default. So if we do that and run that, and then if we click on the field, you can now see that there is a tab character that appears in the text there. And we can also do that if we wanted to put in a new line, characters here. The literal value, if we paste that into another document, it is now split that value up into 2 separate lines, and we can see that it is placed both the carriage return character and the new line character into that piece of text that we had there. So the control character function allows you to place in new line characters or allows you to put in tab characters where they may not have already been put into text previously. Once again, you can combine this function with other functions in order to be able to generate out the text that you need. So here's one example of where you might do that. So in our text, we want to replace the prefix characters that where we have SO space. We may want to change this prefix so that it has a tab after the space. So we can do that by if we combine the replace function with the CTRLChar function. And so what is going to happen is it's going to find and match on any text characters that have SO space, and then what it is going to do is it's going to replace that with SO space and then put in a tab character, and the CTRLChar function will ensure that that /t gets converted into a tab character. So when we click on that, click on the cell, you can see that there is now a space that has been put in that text that we provided. The next JSON XML CSV field function that we've added is called pad. And what pad allows us to do is allows us to pad text with other characters within a text string that is provided. And we can say how many characters it should pad to and what character it should pad with. So let's take an example of this. Say our sales order number was 124324, just as we had here. But maybe we want to say that if the length of this is less than 10, then we want to pad it out with zeros in front to the left of that text there. So what we can use is the pad function. We accept the sales order number field, its value that we want to pad out. We say how large should this text be, padded to. So we say it should be to 10 characters, and we want to pad it with the 0 character. So when we run that, you can now see it has now put 4 zeros in front of the text, which is coming from this JSON string here, in order to make sure it has a length of 10. Now we may not want to use zeros, we could use dash characters if we do that. So you can see now it's putting dashes in front. We could also make the number 20 as opposed to 10. So you can see now we're getting a much longer value, or we could even make it very small, just say do padding when the text value is only 5, and when that occurs, because this text string is greater than 5 characters in length, it will add no padding to it at all. You can also do double padding of characters. So in this example, it's putting 4 dashes in, but we might want to put 2 characters for every space that it needs to pad to. So let's put in the characters hash and exclamation mark, and you'll see that this text string is now actually, it's longer than 10 characters, because what it's doing is put 2 characters for every position that it needed padded to. So that is an example of how you can do multi-character padding using this pad function. We can also set the direction where the padding should happen. So we can either set it on the left side, which is the default way that it does padding, or we could say you want to pad to the right side of that text string. So we put the word right as another argument. And then what you can see now is it's put those zeros into the right-hand side of the text that we were padding out. So that is another optional argument where you can then choose where the padding needs to occur. The next function we've added is called the hash_mac function. And what this does, it generates a hash message authentication code. Now that may sound like a lot, but basically what it does, it is given text and a secret key and uses a certain cipher or cryptographic algorithm in order to generate what looks like a jumbled set of text, but in reality it is a one-way cryptography that allows the values to be then checked to ensure that people cannot easily understand what the original text was. And this is typically used for authentication mechanisms to make sure that the precise value is passed through a hash function. That's what a hashing function does. And then on the other side, where is checking the authentication to make sure that the value of the hashing function matches the expected value. So if we take an example of this function in use, we can just get it straight from the examples that we have in the documentation, and we put it into our query browser. We can now see it is generating scrambled text that has come out of that function. So we can change the text. So what it's doing is it's getting as example text. We might have, say, a typical way you would have a username and password. So your username might be username 1234, and then you might have a password set for that user. So they may have password 1. That's a terrible password if you're ever setting up passwords. But then when you run that query, you can see that it will generate a completely different random number to if you had a different value that is set up there. So that's what the hashing function does, but it always returns the same value for the text and the secret question that goes into it. So we have a few different functions we can use. We're using the SHA-1 cryptographic cipher or algorithm. We can use SHA-256. So we put in the value there. Then now it will generate a longer hash out of that function, or we can use an even longer one, which is 512. So if we put that into there, now you can see that that is much longer again. And we can also use the MD5 cipher. So if we put that in there, then you'll see that it will have different texts generated again. So typically you're going to use this with authentication, and they will, the web service or system that is doing the authentication will say which hashing algorithm should you be generating your HMAC text with. And once again, you could use this function with other functions, such as you may want to do some concatenations, such as the password may have multiple values coming from it. So it may be password 1, and there may be a second value. So you could put that in there, and that will then combine those two together in order to generate out the required authentication credentials that you need to generate this HMAC value with. And this leads to the last improvement we added to the encode JSON XML CSV data field function. So this function encodes, or it basically allows values to be escaped or encoded and then decoded back the other way using the decode function. So it now supports the ability to generate out hashes as well using the SH1 and SHA-256 encryption. So if we take an example of how that looks like, say we're going to hash, that is one-way encrypt the value of the sales order number that we have here. We would put that into the first argument to say which text we want to hash, and then we then say which hashing algorithm we want to use. So we could use SH1, and once again we'll get a one-way encrypted value of what that sales order, that text there that was assigned to this sales order field, its hashed value out. And if we change the hashing algorithm to either be to SHA-256, then you'll get a longer piece of scrambled text. So the encode function is now a very much a multi-purpose function where it can both escape and code text, and now it can do one-way encryptography or hashing using that as well by just setting the second argument is the encoding type that you want to use for that function. So all these functions can be used and combined to do some very sophisticated things within the generic adapter, such as if you're set up a generic adapter like we have here, you may want to use a combination of these different functions, such as if we looked before in our products export, which was getting CSV data out of products, maybe you want to pad the brand field, or maybe you want to substring the barcode field because it has a prefix or a suffix that is included in the barcode field. Or in the description fields, you may want to target certain words and replace them with other words within that field. Or you may want to hash a value which is very sensitive within one of the fields which is stored here. So that all that capability is now available, and it offers a lot of flexibility on how you export data and import data to the different e-commerce platforms. Within the 1.20 connector release, we've added a couple of improvements to the datasets functionality. So if we click on datasets within the connector application and view a dataset that has already previously been created and already has data within it, if we click on the view button, within the products tab, if we scroll across in any of the description cells, description 1, 2, 3, and 4, if that cell has more than 50 characters in length, then we can see that we now get a multi-line text editor that it appears, which then allows you to add more information into that product by pressing the enter key, as we can see here. So this should make it much easier to write much longer descriptions. And you can also do that for the categories as well. If you have categories in your dataset, you can also then give them bigger descriptions there as well. So this should make it much easier for when you want to write paragraphs of text to do with your products or categories. Now you'll notice that if you click on a cell and it only has a small value, by default, the multi-line text editor will not appear. So what you can do to make it appear is if you hold down the Control key on your keyboard while the cell is selected, as well as press the E key, that will then bring up the multi-line text editor as well. So then that will make it easy to then start adding multi-text line editors. So if I go into the categories, for example, we don't have any data for these category rows. If I click on this cell, hold down the Control key and then click on the E key, then I'll get the multi-line text editor where I can then start adding larger descriptions for those categories. And additionally, another improvement we add to the datasets is in the products tab also is this text box called lock ID code columns. So if you click that button and then you scroll across, you'll notice that the first 4 columns will be locked into position and are not scrollable. So that makes it much easier. Say if we were working on the brand columns for these products, we can then go about and set the values for each one of them. And we know precisely which products that we are then adding those brand value data to within there as well. If we want to do this locking off, we just untick the checkbox, and then once again those columns will then be scrollable with the rest of the columns within the products data set here as well. Another improvement we added to the connector in the 1.20 releases is to do with the generic adapter. If we go into the data exports and go into the product cell units, data exports, the product cell units data exports controls the label you see for a given unit that is being sold within the Squizz.com platform or any other platforms that allow product cell units or cell units to be imported into. So if we take our example here in Squizz, we have a product that has a cell unit called pack, we have another cell unit called RL, there's a cell unit called each, and we can see that for each product they can have different labels. So what within the connector, if we go into the data fields here, you'll see that there's two additional fields that have been added called key, cell unit product ID, and cell unit label. So by default, a product will be assigned to a cell unit that is listed in the cell units data export. And so a cell unit could be each pack, container, a box. Basically, it's the underlying identifier of what that cell unit is. But then for each product, even though it may be assigned to the each cell unit, it may label that cell unit as something different. So in this case, this product here may be assigned to the each cell unit, but for that cell unit, it is labeled RL and not labeled each. And same for this one. It's labeled as a pack, even though it is an individual cell unit assigned to it. So that's what the product cell units, this new column does. It allows you to specify the label of the cell unit that is assigned specifically to that product to override it. So if that's not set, then the Squizz platform will default back to the cell units that are entered in the cell units data export. This other field here called key cell unit parent ID, that just specifies if one cell unit is linked to another parent cell unit. So in our example here, we may have a product that is sold in individual eaches as packs as a cell unit, or as boxes as a cell unit, and a container as a cell unit. So a pack may be containing 6 each units, and a box may contain 4 pack units. That's what this key cell unit parent ID, it says how does one cell unit relate to another. A box cell unit, its parent may be a pack, so it's saying that the box is made up of many packs, and then the pack cell unit may say its parent cell unit is the each cell unit, so that way a pack, maybe it's 10 each cell units makes up one pack. So if we were dealing with a pack cell unit, we would then specify the each cell unit as its parent and use its key cell unit identifier stored within here. So these two new fields allow the relationships between the different cell units to be set up, as well as the labels for those cell units to be customized on a per product basis as required. Within the 1.20 connector release, we've added a new data export to the generic adapter that allows us to then export general ledger accounts from any connected accounting or business systems, files, or anywhere where the general ledger accounts are stored. So if we take an example, if we go into generic adapter, click on the data exports, and we scroll down, you can now see that there is another data export here called general ledger accounts. Now when we assign this to a data source, we can see all the fields that are available in order to assign the fields to each general ledger account record that we take out. So if you're not sure what a general ledger account is, if we take an example, if I log into the MyOb accounting system, which we have here, it has this thing called accounts. And under the accounts, if we go into the accounts list, this specifies all the accounts where money is recorded, where the transactions, sales and purchases are made for that business. So we can see that for many accounting systems, they will generally group or classify their accounts. So in this example, we have an assets group or account, and then we have a liabilities account, and then furthermore, we have an income account, and then we have an expenses general ledger account, and then they are further then broken up into sub accounts where they then are very specific. So if you've got expenses to do with advertising, then any expenses you make there will then be journaled or be placed into that against that account to tell you how much the business is spending on advertising. So we can see for this company, for instance, they're spending $10,000 on advertising, and then if we go up to other accounts, then we can see for their assets, for instance, they've got $97,000 in their general checking account there. So all this data that we see here in the accounting system to do with these general ledger accounts can now be then exported out by the connector software using the generic adapter and its associated data source. So if we were dealing with MyOb here, we could use the ODBC data source type in order to read from its database to get these general ledger accounts. Now, the reason why you would want to get the general ledger account data out is so that way within Squizz.com, when you start doing invoicing, such as when you want to then get bills or get invoices from your suppliers, you typically would assign a general ledger account to those invoices to allow them import back into your system and be properly recorded against the general ledger in that accounting system. So the first step would be to find the names of the fields within the underlying database where these general ledger accounts are stored. And you can see that there are a number of fields that are available here. So we have the key GL account ID. So that's the unique identifier of the account. So if we look at, let's just take one of these example, you could use potentially this code here. That would be the key general ledger account if that's how it was stored as the primary or unique identifier of that account within MyOb account, right? And then you've got these other fields. So we get the balance. So you get the balance of that account. In this case, that one's at 0, but you get the field that stores this balance. And then you would place that into the balance field, get the name of that field, the GL account code, which may be the same as the key GL account ID, which would be this value there. And then we've got other fields here, such as the tax code. So these accounts may be assigned to different tax codes depending on your accounting system. So if we look at an example of the GST paid account, we can see that it has a tax code assigned to it. And then we can also set that tax code of which that account is related to. That's what this key tax code ID. So that's the unique identifier of the tax code. And then we've also got the field to also set the name of the account. In MyOb account, right, for instance, that would be the name set here called, this account name field would be mapped to the name field here within the standards. And we've got the description, an account type. So that best specifies the overall type of account it is, whether it's a liability or it is a asset account. So there's a number of options that the standards specify the type of account that you're dealing with, and then you can further it based on class. So this could be current assets, could be the name of the class of accounts, general ledger accounts that you're exporting. So using this data export may be one of the requirements if you want to do invoicing through the Squizz.com platform, allowing automation from invoices being sent as bills from your suppliers to then to assign the appropriate general ledger account to those invoices and allow them to import through the connector back into your accounting system. Within the 1.20 connector release, we've added an improvement to the product images data export to the Todex platform that allows images to first be downloaded by the connector that are hosted on an external web service or website, and then to be then pushed directly up into the Todex platform to the associated project configured for an adapter. So what this allows us to do is greatly automate the handling of images or assigning of images and uploading of images of products to our associated websites. And because of that, that will save a lot of time and effort and money. So within a generic adapter, if we click on the settings, within its generic adapter settings window under the data exports tab, within the product images data export, if we go into the data fields, the path that normally sets the file path to a image can now be changed. And now it can be set to not just a path on the network or of the computer or the local drive where those images are stored. It can now be a URL to an external website or web service. So we, for example, could put in a HTTP or HTTPS protocol into the start of the URL. We can then put our example website where we want to get it from, and then we can say the path to wherever the image is stored. So in our example here, it might be path called images, and then that could have the product image name. And then we may want to use the key product ID or the main identifier of that product to then get the image itself. So if we just take an example, we could have 12345.jpg, and we'll put that in literal text. So all products would then be assigned to this image if it existed, and it could be found on that website. Now, typically what you do, you wouldn't have the same image assigned to many different products. We would typically use a concatenation function, and then we would say, go to that example website, and then here, put in the key product ID or the product code that is then identifies that image. And then after that, we want to then put in the extension of the file as we see here. Now, after that is all done, then the query browser will generate the corresponding file path that we need to use. So if we just test that out, we can see in the query browser, it is putting the data from the key product ID into the URLs, and that's generating the URLs. So then once that is being configured, within the adapter export return schedule, when we run the product images data export and export it to the Todex platform as we've done here and click the run once off button, what that will do is for each of those products, it will then call the URL, try to find the image. If the image is found, then it will upload it to the Todex platform. And it would also advise you within the message logs whether or not those images would be able to successfully upload or not. You'll notice that in our example here that I've always specified the end of the image file names as being the JPEG file format, but if there are lots of different file formats, then you will have to then provide either a spreadsheet file or use a data set in order to store the URLs of those images that have the correct file path and file extension to allow the images to be uploaded. And a reminder that those images must be either JPEG, GIF, or PNG images, and if they're JPEG images, they must be saved in the RGB color profile for them to upload correctly. And the connector will also resize images if they're over 2000 pixels in width and height in order to reduce them down to make sure that they're at a size which is much faster to upload across the web. Within the connector application for the 1.20 release, within the generic adapter, we have added a new tab to the generic adapter settings window called data routines. And data routines allows us to run a specific routine that can then do different things. So the first routine that we've added to the generic adapter is this thing called the generic HTTP GET request routine. And so once we select the routine type and click the routine button, we can again give that routine a name. And what this routine will do is it will create a HTTP request that is a web-based request such as you do in a web browser, and it'll use the GET method in order to send a request across to a web server or a website, just like if you were using a web browser. Let's take an example where we could have let's call it a polling routine. We might want to use this routine to make sure that our website is up and running as expected, and if it is not up and running, then we can use the generic adapter to then send an email advising us that it is not running as we should. So a few of the settings that we have available is that the first setting here is what is the expected code that we should get back from our request when we send it to our website. So a 200 means an OK response, and if you ever seen a 404 response before in the web browser, that is the website is unavailable or cannot be found, the page that you are requesting. So that's just one of many different codes that a website or a web service may return. So we can specify here exactly what that code is that we are expecting to return when we call the URL. When we call the URL, we need to specify the protocol, so that can be either set to HTTPS, which is a secure connection, or HTTP, which is an insecure connection. So generally, websites these days running publicly are all using HTTPS. So that's what the protocol would normally be, unless you're running it on a local server or it doesn't need to be secured. The next thing we would set is our URL to our website or web service, may be called example.com and URL, and we might have a thing called test connection. Might be one of the URLs that we can request. So once that's done, we can also specify the timeout. So how long is the connector willing to wait to get a response back when calling this URL? So by default, it's set to 30 seconds. You may want to reduce that to 10 seconds or make it as long as 60 seconds, depending on how long you think that the connector should wait for. So you generally want to keep it at quite a small value, unless it is doing a lot of processing that is happening on the other side of where the web service is getting called. Now, when the web service returns a OK response, you may want to further validate the response that is returned by the web server. So we can put in a regular expression, that's what regex stands for, that we can try to find certain pieces of text that are returned by that web service in its response body. So we might want to just find a literal text called success. If the word success returns in the response returned by that web service, then we know that we have a good result at the end, or a successful result at the end. But you could do much more complex regular expressions, and I would recommend doing tutorials on regular expressions if you want to go to that level, since they can be quite detailed and quite complex and very powerful at the same time, where you can match certain patterns that are coming back from the text. So once we've got all those settings configured up, there's no data fields that need to be set. So then this routine is ready to then be run. We do that, we close this, we make sure our settings are saved. Within the exports routines window, under the routines tab, we can now see that new routine that we added to that adapter, and then we can click the run once off button to see if it will successfully run or if it fails to run. So we click the run once off button, and you can see then in the logs whether or not that was successfully run or not. So you can see that there's an error here. So in our example here, the server returned a 404 not found. So that it was a failure that had occurred for that because we're calling a incorrect URL. But if it succeeds, then also you will see in the history log here if that has successfully run, or if it has unsuccessfully run, that will appear here, and then you can view the details of that routine as well. So that is one example of where you can do this routine to do polling, but you could use it for other things. You could also use it for calling actions to occur on other linked web services. So if you've got multiple connectors running, you may want to call a specific action or function or data to export on that other web service to happen as well. That is possible. And you could write your own web services that do a lot of complex processing, and then you could have multiple of these different routines set up to be able to do that. So if we showed an example of that, we'd just create another routine, and we'll call it, let's say, poll 2, and we'd set up all the credentials for that poll. And then within here, we could then schedule both of these polls to run at specific times of the day and do the polling that we need to do, or do whatever is required for that web service. It can be quite a powerful tool to automate different functionality being used within web services and reporting. The last improvement added to the 1.20 connector release is the ability within the generic adapter to be able to set up data hooks, to be able to paginate and call web services multiple times and start the pagination off at a different records ID. If we look at the generic adapter settings window, one of the data sources we've set up is to be able to export data from XML files that are coming from a web service. So within its HTTP web service settings window, we've got the data type set to XML, but we can set this setting here. How many records do we expect to get per page? So this could be set at 100. So this tells us that the web service that we call to get our product data limits the amount of products that can be returned to 100 records. And that means if there's 1,000 product records, then we need to call that web service 10 times in order to get the full 1,000 records with 100 records per page. So if that setting is set there, the web service being called at the other end, we may need to provide what is the starting position or the starting record to get the next 100 records. Now, for some web services that you just provide them the number, you tell them to get the records from 0 to 100, and then from 100 to 200 and 200 to 300. But for other web services, they may require you to provide the specific code of the product to start getting the next 100 records from. So this is when we've added a new data hook that is available for when the data export is assigned to a JSON XML CSV data source type. So that hook, if we put into our URL this identified called last key record ID, and let's say it had a attribute called product code in the URL, and that had to equal the next product code ID. By default, for the first page of records being requested, that last key record ID is going to be blank. And if that web service allows it, then it will start from scratch to get the first set of product records. But once the first page has been obtained, whichever field of the data coming out is assigned to the key product ID for the 100th or the last record in that first 100 records, it is going to assign this value here, last key record ID will equal the key product ID, because key product ID is the main identifier of a product. So that will then get placed into this data hook, and that data hook can then be embedded in the URL. And then when the next page gets of products needs to be obtained, say the records from 100 to 200, you can specify, well, the last product code may start with D, maybe DAB123. So then that will then get put into here and replaced with DAB123. And then the web service would know, find me all products that start with D. And if they're ordered alphabetically, then it will get the next set of 100 records. And then that data hook then would be changed again to maybe the products that start with E. And it'll get 1, 2, 3, 4, 5 and get all the products that start with that. So that's what this last key record ID allows you to do for when pagination is turned on within the data source. When it is given a value which is greater than 0, then within here, it will then place the last key identifier or the record ID or the key product ID of this hook, which allows you to get the next page of product records. And it will keep doing this until there is less than 100 or less than the amount of records that is specified within this parameter here. So as soon as we get to say the Z products, maybe there's Z products that start with that, if that page only returns in 50 records, no further request will be made to the web services to get that. Now what will happen is the generic adapter will then combine all these pages that contain 100 records, combine them into one record set of data, which can then be uploaded or exported out into the corresponding e-commerce systems configured in the connector. This data hook is very much required when the web service you're calling to get records from has pagination turned on and limits the amount of records that you can retrieve in one hit, and then it also requires you to enter the identifier of a record to start retrieving records from. So this key last record ID value will change depending on the data export you're using. So for payment types, for instance, the key record ID will be the key payment type ID, since that's the unique identifier of a payment type. That's the unique identifier of that. It is important to look at key identifiers of a given data export in the data fields to know which one will be the last key record ID. Now there can be multiple key identifiers, so then this hook can have the value key record ID 2 and 3 to allow you to use the other identifiers that are available when there are multiple keys, such as product images, for example. There are 2 key identifiers, which are the primary identifiers of images. So that's when those additional hooks can be utilized. And also, you can have different values to whether or not they're URL encoded or they will XML encoded. There is also the ability to set that as well. And I would recommend reading the documentation. So within the generic adapter documentation, we can see where these data hooks are listed. So we can see the full names of them to see what's available there. And so you can have URL encoded data hooks as well as XML encoded data hooks. So you can also place these data hooks within the body as well as the HTTP headers of the requests to allow them to be placed there instead of within the URLs themselves. That is also possible. So when you run these data exports, you will see in the logs the pagination of these URLs, and you'll be able to see the actual values that are substituted for the data hooks and see if you've correctly configured it or not. And if you have not correctly configured it, you've got to make sure that the pagination doesn't last forever if you're always returning the same set of records to begin with. So be very mindful when you're first setting this up to make sure you get the right keys, you use the right identifiers, and set up the right properties for how big the page sizes need to be for the generic adapter. And that's a wrap up of the 1.20 connector release. For more information about this release and others, go to the squizz.com/docs/connector documentation center, where you can find more information about what is happening. Subscribe to the YouTube channel to receive notifications of when new videos are updated, as well as you can follow the squizz.com connector feed by going to squizz.com/squizz, and also log in and sign up to the platform, where you can then have an active discussion within the feed there about everything that is going on as well. Thanks for taking the time to listen. Till next time, have a great day.